back to the channel. I'm the GCSE science teacher. In today's video, we're going to be learning about molten electrolysis and also specifically focusing on the extraction of aluminium from aluminium oxide and its ore bauxite. So if you do find this video helpful, feel free to give it a big thumbs up, share it with someone. Please do subscribe, join the channel here. It's absolutely free. I make biology, chemistry and physics videos for GCSE students here. So if you'd like support, feel free to, be part of this community. Click the bell. You'll get notified every Sunday at 12 noon of my new uploads. So thank you in advance, by the way. I do appreciate every one of you. I really appreciate the lovely comments you guys always write and the requests, everything. It's just such a lovely community here. So thank you so much. I can't believe as well, as an actual teacher, I cannot believe I have around the same number of people that a school would have. It is just mind-blowing to me that people have actually subscribed. So thank you so much. And I'm really glad you guys find this helpful. So I have made videos already about electrolysis, but in case you missed them, I'll link them for you. And let's just do a little, like an introduction, like a recap. Electrolysis is the splitting of something using electricity. Electro meaning electricity, the movement of charge, and lysis is just the splitting up or the separation of something. So in an ionic compound, if we melt it, we call this molten. So I always think about like molten chocolate desserts because I love chocolate, but also because molten just means melted. So we've not mixed it with water, nothing like that. That's aqueous electrolysis, you guys. I've done a whole video on that. I'll link it for you. But molten electrolysis, we've literally got the compound and we've just melted it. And this causes the ions that are within the compound to be able to move. They're free to move. And therefore, the charge, the movement of charge is the electrical component. The movement of charge is electricity. And this is why electrolyte, the stuff that we've made molten or melted, this is able to flow to the anode or the cathode, and therefore we can extract substances from it accordingly. So let's talk about what sorts of things we need to know. So you will need to remember the reactivity series for this topic. I have done a whole video on it. I'll link that for you as well. But remember, the reactivity series just shows you the position of metals in order of reactivity. So the most reactive ones are at the top, least reactive are at the bottom. Potassium is the one that's the most reactive. Usually the ones that end in -ium, like I've said a few times before, these are the ones that are nearer the top. The ones in the middle, the smaller words like zinc, iron, tin, lead, they are kind of reactive, not really, they're in the middle. And then you've also got all the precious metals like copper, silver, gold, platinum, the ones that are used for jewelry and coins, they are at the bottom and they are least reactive. That's just the way I remember it. If you can kind of remember roughly where things are, it just gives you a bit more ability to make predictions, which is something that you are being asked to do in this topic. Really, you're making predictions based on the electrolyte. So even if it's like a flashcard that you make, or you just make a sticky note and you put it somewhere and you can see the order all the time, it helps you remember it, because you don't unfortunately get given that in the exam. So the reactivity series, that was a bit of a recap for you. But what you need to know in terms of molten electrolysis is this idea that electrolysis is used when the metal itself is too reactive to be extracted using a method called reduction with carbon, or if the metal itself actually reacts with carbon. So you can see in the reactivity series, we've got all the metals, but then we've got two non-metals in there called carbon, and the other one is hydrogen. Hydrogen is specifically for the aqueous electrolysis topic that I made a video on, so I'll link that for you. But the carbon is what we're interested in today. So any metals above carbon are way more reactive, and therefore we can extract them using electrolysis. Anything below carbon, so zinc, iron, tin, and lead, we actually use reduction with carbon. We can heat it with carbon, and they will be extracted in that way. But things such as sodium, lithium, potassium, calcium, magnesium, aluminium, all the ium metals, ones that are usually in group 1, they are very, very reactive, and therefore you would need to use electrolysis to extract them from their compounds. And we're going to look at specifically today what happens when we try to extract aluminium from the aluminium oxide compound. So we're going to look at that specifically now. So, products which form at the cathode and anode is something, like I've said before, you'll have to get used to doing and predicting. It's very easy for molten electrolysis. It is also pretty easy for aqueous electrolysis. This is just something, however, the more you do, the better practice you have, the more confident you'll feel. At the beginning of this topic, lots of students find this really hard and hard to contextualize and understand what is going on. But the more practice you have, the better and easier it gets, I promise you. So stick with it. You are doing really well. The fact that you're here is great. So products which form at the cathode, at the anode. At the cathode, remember this is the negative electrode, so positive cations will be attracted to the cathode. Metals are always going to form positive metal ions or cations, and this is because they have the ability to lose electrons. So the positive cations, which are metals, are attracted to the negative electrode, the cathode, and they gain electrons. This means that a solid metal will form and coat the electrode, and you will see that physically. At the anode, however, this is all the non-metals that form, so negative ions. This is the anions. Those anions are attracted to the positive electrode, the positive anode. And what forms is this substance, which is a non-metal. Usually it's a gas, and it depends on the gas that forms. I'll explain a little bit in more detail. Usually it's oxygen, something like this. It depends what the electrolyte is. But you'll see like bubbling, fizzing, effervescence, and you'd be able to actually collect the gas in like a test tube and test what gas it is. So this topic really does link to other topics as well. So it's nice to kind of have that cross-curricular link when you are revising. So yeah, let's look at a very specific example, which is the extraction of aluminium. This slide was more just generally what happens at the anode and cathode with molten electrolysis. So, the extraction of aluminium. Remember, aluminium is extracted in the first place because it's a metal, it's highly valuable, it's very useful, it has lots of utility, and that's why people are doing this in the first place. So, where does aluminium come from? Well, it's a finite resource because it's a metal and it's found in rocks, which we call ores, O-R-E. The rock is called bauxite and it has aluminium oxide within there. So, aluminium oxide is just aluminium and oxygen combine together to form this compound. And we extract the aluminium oxide and we extract the aluminium from it using electrolysis. So you can see we have a beaker, we have our electrolysis solution called the electrolyte, and we've just melted aluminium oxide. We've mixed it, however, with something called cryolite, which helps to reduce the temperature needed for this reaction and therefore lowering the cost. So, one of the questions they could ask you in the exam is why cryolite is needed in the first place. And you would say it reduces the energy demand, it reduces the temperature for this reaction, and therefore it makes it less expensive for people to do. So, that's why cryolite is used. It also helps with conductivity as well. It helps the actual reaction move so the ions can move and therefore actually make the reaction a bit easier to occur. And also the densities. Aluminium itself is much more dense, so it will literally just fall to the bottom of the chamber compared to cryolite. So that just makes it easier for the extraction process. So there are quite a few reasons why this is the case. So anyway, once we have the aluminium oxide and the cryolites mixed together, we turn it on and here we are. We have substances that form. So at the positive electrode, the anode, the negative ions move there, so the anion. So the oxygen ion, which is the O2 minus ion, will move towards the positive anode. Remember, the oxygen comes from the oxide part of the aluminium oxide. And what happens is the oxygen will start to form because essentially oxygen gas will form from the oxygen ions. I'll show you the half equations in a second on the next slide. So if you are a high tier student, you'll be able to see those. But what's really interesting is the positive electrode actually starts to wear away. And this is because the oxygen that forms actually reacts with the carbon and forms carbon dioxide. Now, usually you think to yourself, well, I thought electrodes were not reactive. They are inert. But in this case, oxygen does react with carbon that is found within the electrode. That's literally what the electrode's made of. And we get carbon dioxide gas that forms, and that literally wears away and breaks down the electrode. So it needs to be replaced over time. Again, this is a sort of question they could ask you. They could say, why is it so expensive, this whole process? And it's because those electrodes need replacing, at least the positive one does. At the other electrode, the negative electrode, the cathode, we have the cations that form or move towards it, and we have, in this case, it's aluminium that is the cation, that's the metal. So the aluminium ion will move towards the cathode, and eventually solid aluminium will build up and form there. So these are the two products that form in this case. So if you're a higher-test, you'll need to know some half equations. Remember the phrase oil rig: oxidation is loss, reduction is gain. Oxidation is the loss of electrons, reduction is the gain of electrons. So at the anode, we have the oxidation, so the loss of electrons. You can see in this case, we have our 2O2 minus ion that forms oxygen gas and 4 electrons. You could be expected to balance these half equations. So if you remember that oxygen forms a 2 minus ion, and oxygen is a diatomic molecule, so O2, you'll be able to see that, well, O2 is neutral, it has no charge whatsoever. But O2 minus, well, there's 2 minuses there. So we need, on the other side of the arrow, 2 electrons, but then we have 2 oxygens on the right-hand side. So we need two lots of O2 minus, and therefore we need 4 electrons. I have done an entire video on balancing equations. I will really recommend you guys watch that if you are not sure how to do this. I'll link it for you as well. You also need to know as well that the oxygen then combines with the carbon and forms the CO2. So that's just an additional equation for you. Now at the cathode, we have the reduction of that substance, the reduction of aluminium. So Al3 plus reacts and binds with 3 electrons, or it gains those 3 electrons, I should say, and that will form the aluminium. And essentially what you're doing in these half equations, students find this quite tricky, but you just want to make sure the charges balance, just like you would with any equation, really. You want to make sure that the charges will balance. So you can see on, for example, the aluminium, you've got 3 plus and 3 minuses from the electrons. That gives you overall neutral or 0. So if you think of it in just basic maths, it makes it a little bit easier for you to work these out yourself. So remember, with everything, don't forget those key components that got you to this topic: ionic bonding, gas tests, reactivity series, redox reactions, displacement reactions, the reactivity of group 1 metals. These are the sorts of things that they love, love, love at GCSE to link together with topics like electrolysis. So just remember, when you're revising, try not to see everything as a singular topic. Everything actually links together. Even within physics and biology, they all link with chemistry as well. There is massive overlap. So if you can strengthen your knowledge by strengthening those curricular links, you will be onto a winner, and you should get some really exciting results in your GCSEs if you do make those extra steps to revise. And that's it from me today. I've been the GCSE science teacher, and you have been curious. If you did enjoy this video, give it a big thumbs up, share this with someone you know would benefit from learning more. And of course, subscribe if you haven't already. It would be amazing to have you here. Thank you so much for all your support. You guys are incredible. I hope you found this video helpful. And if you have any video requests, please let me know in the comments section. Have a great day. Take care, and I will catch you in the next one.